And so when we were trying to solve this type of problem, what was our strategy? Yeah, okay, so, yeah, in a general sense, we were trying to find the answer, that's true. But if we were to break that up into steps, if our cost of our shirt was $16 and our selling price was 28, what would be our first step in order to find that answer? Mm-hmm. Mm-hmm. And now, why did you put 16 on the bottom instead of 28? Yeah, that's exactly right. Right, we have this equation right here. Percent increase is equal to the amount of change divided by the original quantity. Good, so that's what we worked on last week. And in this type of problem, the things that we knew were the cost and the selling price. Right, this is what we know. And what we want to solve for is the percent increase, right? So now let's say we're given a problem like this. And this is one of the problems off of your homework. We're going to use it to sort of walk through this process. So if in this problem we know the cost and the selling price, and we're trying to solve for the percent increase, what if, for example, we have a problem like Robin ran a total of, let's just say she ran 48 miles. And this week she wants to run 25% more miles. And what we're trying to solve for is how many miles does she need to run in order to increase this number by 25%. So in this case, we know something slightly different, right? Instead of actually knowing the cost and the selling price, or this sort of lower and higher number, we know this original quantity, and we know the percent increase. And what we want to solve for is the number of miles. So to relate it back to like a cost problem, it would be like this selling price, right? The original number of miles, or this 48 right here, would be like the cost, the lower number, and we're trying to solve for this higher number, this $28. So in this case, what we know is a little bit different, so our strategy has to change a little bit. So let's say we're still working on the same problem where she's running 48 miles and she wants to increase by 25%. Now, how many miles does she need to run? Okay, so what we need to do is figure out sort of what number does our original quantity need to increase by in order for the increase to be 25%, right? So we almost have like 48 plus some number is equal to some number, right? And this number is our answer. So how we do this is a little bit different. We use a different type of equation. So in this case, we're talking about something increase, right? So we're talking about a percent increase. And when we're doing that, we have this equation that's right here. And it's our bigger number, or if we're trying to relate it to cost, for example, it's the selling price, or the bigger number, is equal to 100 plus the markup, or another way to say this is the percent increase multiplied by the smaller number. So we can almost relate this to this idea here, right? We have 48 plus, or in this case multiplied, some number to get our answer. And in this case, our bigger number is our answer. This 48 is our smaller number. And this chunk right here is going to be this number right here. Does that make sense, kind of, so far? Okay, let's keep walking through. I'm just trying to get you to conceptually understand where this equation comes from. But this is the equation that we're going to be using throughout this is... Oh, okay. It's this bigger number, right? So, okay, so we know that this number wants to increase, right? Because we know it from the problem, right? We're dealing with this percent increase. So our answer is going to be greater than 48 miles, right? So if we use this equation right here, we have our bigger number. And which one's our bigger number in this case? Our 48 or our answer? Okay, so we're talking about a percent increase. We want to increase this number 48 by 25%. And the number that we're trying to find is going to be bigger than this 48, right? Because say, for example, I have 10 watermelons and I want to increase it by 25% watermelons. Am I going to have 80 watermelons or am I going to have 120 watermelons? Right, because, or some number, right? I just made that up, but it's going to be some number that's greater than our original quantity. And so, in this case, our answer is the bigger number, right? So answer, what we're trying to solve for, is equal to 100 plus the markup or the percent increase. And in this problem, what's our percent increase? 25%. And do I need to write this 25% in a different way before I plug it in? That's exactly right. Actually, excuse me, we're going to be doing that a little bit later. So in the original sort of... Well, okay. I think you're more used to changing this to a decimal before you plug it into an equation, right? Okay, so there's another way that we can actually write this to make this a little bit easier. What we can do is we can say our answer is equal to 1 plus our percent increase, and we can write this as a decimal times our smaller number. So in this case, we have our answer is equal to 1 plus 0.25. We know our bigger number, right? Our bigger number is our answer. And so the other number that we're dealing with is 48, so that's going to be our smaller number. So we're going to multiply this by 48, our smaller number. Okay. Now we just sort of solve this through. So it's 1 plus 0.25 times 48, and we get our answer of 60 miles. Okay, so I just wanted to sort of run through the idea conceptually, like where we get, you know, this equation right here. But this is our equation for this type of problem. It's going to be our bigger number is equal to, and let's write it this way. Our bigger number is equal to 1 plus our percent increase multiplied by our smaller number. Okay, so let's try an example using this idea. Okay, so let's say I have, let's use the watermelon example. So let's say I have 100 watermelons, and I want to increase this number of watermelons by 20%. And what I want to find is the number of watermelons that I'll have after I increase it by 20%. So when we're talking about an increase in watermelons, like in this problem, the number that we're given is going to be our bigger or our smaller number in this equation. And what we're trying to solve for is our bigger number. So we have our bigger number is equal to 1 plus our percent increase. And what's our percent increase in this problem? And how can I write that as a decimal? Multiplied by my smaller number. I'm talking about a percent increase, so the number that I'm given is my smaller number. So I'm going to plug in 100 right here. Now let's go ahead and do this math. What's my first step in order to solve for this answer? Good, and I like that you were sort of thinking about the process from the beginning. That's good, and that's exactly what we're going to do in the next example. Okay, and so let's go ahead and plug this into our calculator. 1.2 times 100, and let me know when you get an answer. Good. So 120 watermelons. Okay. Sorry, what was that? Okay, good. Well, I'm glad you were able to correct that. That's good. Remember asking those questions. My answer makes sense. And let's say, does this answer of 120 watermelons make sense? If we have this equation right here, where our bigger number is equal to 1 plus our percent increase times our smaller number, well, is our answer bigger than our original quantity? And what was our original quantity in this case? And our answer is 120 watermelons. So, does this idea make sense, or do you have any questions about it? Okay, so I have an idea. Then tell me if this is the way your teacher explained it. Did you first sort of multiply this number by this number and then do some addition or something like that? There was like multiplication and addition? Right. And so in order to do that, you sort of have to understand, like, right? Because when we're talking about this equation, right, we're not just talking about numbers, we're talking about an idea, right? We're talking about, this number right here, this 1.2 actually represents something. And the way that your teacher taught it, it's the right way, like it works. But in this way of doing it, we can simplify it to one equation that we can plug in every single time, and it's going to work. And guess what? If we're given the bigger number rather than the smaller number, we don't even have to think about subtracting instead of adding, anything like that. We can plug it in this equation and solve. So this way is a little bit more helpful for you. Right. And it's too many steps. That's why I really like this way, because it makes it nice and easy. We have one equation, and if we know the equation, then we can solve any sort of problem. So I'm really glad that this is actually helpful. So let's just keep running through some of these sorts of problems. Actually, before that, do you know when your homework is due? It's due today. Okay. That's good to know. I should have asked in the beginning because then we need to solve through that. So we're going to work on this types of problems more throughout the week, but let's start rolling through the homework. Sound like a plan? All right, cool. Have you started it yet? Okay, so you did problem 1, problem 2, the one about the snowstorms, the one about the music store, and then we have to do the one about Robin running the miles and the pair of boots. Is that right? Okay, cool. So let's go back to our problem that we went through the first time, the Robin example, where she runs these miles now that we know that this equation right here. Okay, so last week, Robin ran a total of 48 miles. Okay, so she ran 48 miles. Cool. Then this week, she wants to run 25% more miles. How many miles does she have to run this week? So how many miles does she have to run? Okay. So in this problem, are we talking about a percent increase or a percent decrease? Sorry, can you repeat that one more time? Okay, and why is it an increase and not a decrease? That's exactly right. And so that's always going to be our first step in these types of problems. We're going to ask, is it a percent increase or a percent decrease? Because there's actually a slightly different equation for a percent decrease that we also have to know. But as long as it's a percent increase, we're good to use the equation that we know. Okay, so we've established it's a percent increase. So we can use our equation. Right? Our equation right here, our bigger number, is equal to 1 plus the percent increase times the smaller number. In this case, is 48 going to be our bigger number or a smaller number? Okay, and why do you say that 48 is our bigger number? Okay, that's true. But this 25, isn't that this percent increase right here? It is the smaller number. So, first thing we can cross off our list, right? We have 3 parts of these problems, right? So we have, right, this, and then we have some number that we're trying to solve for. Each of these 3 parts are going to correspond to one of these sort of variables or words that we have written right here. So, and when I mark things like this, just know that when something's yellow and then marked yellow somewhere else, I'm talking about the same idea or the same number, okay? So we have this 25%, and that's our percent increase, right? Now, in this problem, we're talking about a percent increase, right? So we're going to have this number be bigger, right, when we have our answer. So we can sort of ask ourselves, our answer is going to be bigger than 48. So our 48 is our smaller number. Does that sort of make sense? Okay, cool. So let's go ahead and start plugging this in. Bigger number is equal to 1 plus percent increase times our smaller number, which is equal to 1 plus, what's our percent increase in this case? That's exactly right. And we plug it in as a decimal. Times our smaller number. And what's our smaller number in this case? Equals our bigger number. Okay, do you have any questions how we set up this, about this equation? Maybe like, how do I find out what the smaller number is and what the bigger number is? Or how do I find out what the percent increase or anything like that? Okay, that's a really good question. Okay, I'm going to have a rule, and when we have rules, it makes things easier for me to think about, so hopefully this will help you. If we're talking about a percent increase okay. Here's why I'm hesitating, because there are going to be types of problems where we're actually given this bigger number instead of the smaller number. And so when we're given the smaller number first, and we're told, for example, you know, like what we're told in this problem, it's sort of obvious. So in this problem, let's look at how it's worded. So last week, Robin ran a total of 48 miles. And this week, she wants to run 25% more miles. So in that case, we're saying, okay, she ran some number. She wants to run more than that number. Now, we can be given a problem like this, where Robin wants to run 65 miles. She ran some number last week, and that number increased by 25%. So really, how we know is by the words in the problem. And so I'm not sure if you're actually going to get the other type of problem that I'm talking about, so let's just make the rule very, very simple. Excuse my thinking out loud. If we're talking about a percent increase, the number that we're given in the problem is the smaller number. I'll say that again. If we're talking about a percent increase, the number that we're given is the smaller number. Does that make sense? Good. That's exactly what you should be doing, because the more rules that we can get written down and that we can look at later, the easier it's going to be to sort of understand. Okay. Good. So are we ready to continue on this problem, or do you still have any questions about this? Okay, cool. So we have our bigger number is equal to 1.25 times 48. 1.25 times 48 is equal to 60. And that's our answer. Do you have any questions about the calculations on this part? Okay, good. We are almost out of time, so let's run through this last problem really quickly, and we can get out of here. Does that sound like a good plan? Awesome. Okay. So, a website used to sell a pair of boots. Okay, so we're talking about percent decrease now. Okay. So, a website used to sell a pair of boots for $84. It is now selling them at a 30% discount. What were the new discounted price of the boots? Okay, first question for you. Are we talking about a percent increase or percent decrease from this number? Why is it decrease? That's exactly right. And when we're talking about percent decrease, we actually have a different equation. Now, I'm going to teach you this equation tomorrow, and we're going to practice a little bit more on Thursday. But just for now, because we need to get this homework turned in, I'm just going to run through it, and I'm just going to give you the equation, okay? Okay, so our equation for percent decrease is our smaller number is equal to 1 minus our percent decrease times our bigger number. Does that look similar to our other equation at all? It's subtracting 1 and our bigger numbers on the other side. That's the only difference. Other than that, we're talking about the same ideas. Also, in percent decrease problems, the number that we're given is the bigger number. So it's almost like the percent increase problems flipped around. There's a subtraction sign, the smaller number's on the other side than the bigger, and we're given the bigger number instead of the smaller number. Like I said, we're going to go into this a little bit more in depth tomorrow. Practice it, make sure we understand it, but just for now, let's just get it done and plug these numbers into the equation. So this number right here, the number that we're given, is our bigger number. This 30% discount, is that our smaller number or percent decrease? And what's another way to write that percent decrease as a number? Times our bigger number, which is 84.